All right, we're going to make a least recently used cache. And we're going to want to definitely make a get method and a set method for getting the value of the key if it exists in the cache, and also for setting the value or inserting the value into the cache if it doesn't already exist. And then, of course, keeping track of the least recently used items that we'll delete as our cache fills. So we're going to go do this by creating a map, and we'll map the items. We'll map their key, which will represent kind of the lookup or the value, and then we're going to put in, for the value of our map, we're going to put in a pointer to a node that's going to contain the item's data as well as the key. And the linked list will keep track of the order in which we've seen these items so that we can quickly delete the least recently used item. So to give a little example, if we have kind of these data sets, key 1 with data 1, key 2 with data 2, key 3 with data 3, and key 4 with data 4, and then maybe we got key 2 again. Okay, so what we would do is we would make a map, and as we add to the map, we would say, okay, K1 isn't already in the map, so we're going to add K1 with really a pointer to D1. So I'm just going to say node 1, and it's going to create a node that has K1 D1, and it's going to this one would start as the start and the end, and its pointers would be just pointing to null. And then the next item, we would say, okay, K2 is not in the map, so it's going to have node 2, like a pointer to this node, if this were node 1. And then this will point to node 2, and we'll insert at the head. So this would be node 2, and it's going to contain K2 and D2, and it will set its next pointer to point to this, and then its previous pointer would point to null, and the previous pointer of this would be set to point to 2 as well. And we would change start to be here, and end stays there. This is still null, and this is null. Okay, and then we go in for K3, and so it's not in the map, so we put it in there, and it's going to end up pointing at node 3, and we'll want to insert at the head, so we'll have node 3 go here. So we can, and that's K3D2, D3, and it is going to point here, and this one's going to point here instead of null, and that would point to null up here, and our start would move to 3. Okay, and let's kind of give ourselves some more room here. Okay. All right, so then we have K4. It's not in the map, so we have K4. We'll end up pointing that to node 4. And that would go here. We're just going to call it node 4, and it's got K4 stuff in it. So then this one would no longer be pointing to null. It's going to now point to this. And this one will point to this node. This will be null. And start moves to the beginning. And then lastly, it looks like we have K2, D2. So K2 does exist. So it's going to look in the map. It's going to see that it exists. And then it's going to come down here. And it's going to know it's pointing at node 2. So it comes down here to node 2. And it's going to actually move it to the head. So what we have to do is reroute. So first we reroute 3. We'll point it over here. And we reroute 1's previous, point it there. And then 2 is going to have, 2 is now kind of removed. It's going to have no more pointer here. It's going to be set to null. And so what we will do is 2 will then have been removed, and then now we're going to move it to the head. So it's going to move over here. And now its next pointer goes to node 4. Node 4 goes to node 2. And the start goes to the beginning. So that's kind of the general idea in order to keep track of the least recently used items. So let's go ahead and write this up with some code. Let me clear some space. Okay. So, okay, first things first, we're going to make a class and call it LRU. And actually, we don't want that. Okay. And then inside our class, we know that we need to make a dictionary. And it's going to store, in our example, we'll say that they're strings and a node. And so we'll call this map and equals a new dictionary of string and node. And actually, before we get too far in, let's go ahead and define the node. So we'll just make another class of a node. And in it, we will have, let's see, we definitely need we need the data that we're going to store. So we know that's a string. We actually will want to get set. We also need to have our key. You know what? We'll probably want these to be more like an internal. And our key is also a string. And we'll get and set. And then we want our node of next. And lastly, we're going to have a previous. choose a type node. Okay, and so we can just do it as such. Okay, so there's our node. And then we're just going to go in and finish up our LRU class. So we know we want to keep track of the start and the end of the linked list. And we also know we need to keep track of the cache size. Let's go ahead for this example, say the cache size is 4, so it's quick for testing purposes. And then we'll go ahead and make our get. So and this is just going to return the data that's inside the node. So public string, we're going to get, and we need the key. Okay, so basically what we need to do is if there's nothing in there, if it's not already, if it doesn't exist, we're returning -1. Otherwise, it needs to be in the map. So we can say, okay, if the map contains key of, let's see, let me just say of key. Okay, then we know that we need to make it into kind of a node so that we can pass it in and we can say remove the node. Because what we're wanting to do is move it to the top. What it's basically saying is you just accessed me again, so now you're not the least recently used item. So wherever you are in this linked list, we're going to move you to the very front of the list because we delete the least recently used item from the end of the list. So this is its way of keeping the order, and we will write a remove node function. And then we also want to then add it to the head of the linked list. And then we're going to return the node data. Okay, and as we said, if it's not in the list, we're just returning -1. Okay, so there's the get function. Let's go ahead and we'll do the remove and add functions last. Let's go ahead and do our insert. Also known as set. Okay, so string, and it's going to need the key, and it's going to need the data that we are setting. Okay, so first scenario is that the map does contain the key. It already exists, so in that case, we just need to update. We need to update it to the top. So, and if the value happened to change, you can update that too. So, okay, so we've got somewhere to store this. Okay, so And then we're going to remove the node. And this is again us moving it to the front of the line. Okay, so that's the first scenario. So if the map does contain this item, the other option is it doesn't contain it, it's a new item. And in that case, we're going to there's a new node. Okay, and then in this, we're going to start it with setting the previous equal to null. Let me make sure that's what I called it. One sec. Yes. Okay. Prev. All right, and then we're going to set that next equal to null, and then we want to set the data equal to data and the key. All right, so then we need to double check before we do anything and see, is our cache size, are we full? Are we at full capacity? So if we are at full capacity, which we'll know if our map count is greater than the cache size, then we first need to remove from the map Okay, so first we remove from that. Then we need to remove that node that is extra. And we want it to be the end node. So, and as I did with the remove, I want it to be the key of the end node. And then we will put the new node in the front. So we've removed to the least recently used item. We've added our new item to the top of the list, or the head of the list. The other option is that we're not at capacity, in which case we just want to add this new node. So add to head new node. Okay, and then lastly, we definitely want to make sure that we added this to the map. So map.add key and new node. Okay, so that is our, let me make sure I got, that is the end of our insert function. So now we need to write the remove node and the add to head. So okay, I want to definitely, we'll do the remove node. And it's going to take a node. Okay, so first we want to see if there's a previous one. So if node.prev, oops, does not equal null. So if there is a previous node to the node that we want to remove, we're going to reroute that. to skip over. So node.prev.next equals node.next. So we want to get to the node that's past the current node that we're looking at. So we're routing around. Else, we know that we want the, in fact, we'll just do it like this. Else, we know that we want the start to equal the node.prev. And then we want to check and see if the next node does not equal null. Then we want to make sure that we route that node accordingly as well. So node dot okay, so this is going to set the next node's previous is now pointing to the current node's previous. So we've routed it around the current node so that it will know where to point. And then otherwise, if there wasn't a next, then we're at the end of the list. So we want to make sure that we set the previous node to be the end. Okay. All right, so that should do it for removing the node. We've now routed around it. And we're able to route around like this because we're using a doubly linked list. And then we have to do is the add. So called that add to head. And it takes a node. Okay, and then okay, we're going to put the next node is equal to start, and then there's nothing previous because we're putting the head we're putting it to the head, so there's no previous. And then if start does not equal null, which means that start was pointing to something, then now start is going to point to the new node. So we say start equals node. And then if the end equals null, where we were at the end, then we know the end equals the start. Okay, so that should take care of adding to head, and it should also take care of our class. So let's go ahead and test this out. We'll have to kind of scroll as we go. Okay, so let's go ahead in here and we can say, okay, we've got a dictionary, so we need to keep track of that. And we have our cache size of 4. Let's put it here. So we'll keep track of that. Okay. And then if we want to add this first item, it's going to go down into the insert function. And it gets K1 and D1 as the key in the data. So if map contains key, which it doesn't, then we come down here to node equals new node. So we make a node and previous equals null. Next is null. Then we've got our data, which is K1, D1, and our key. All right, so if map count is greater than cache size, it's not. So we go into the else, add to head, new node. So we're going to send this node down to our add to head function. And it says node.next equals start. Okay. And node.previous is null. I'll put this start here. And then if start does not equal null, which it does, start.previous equals the node. So we want to skip that because the start does equal null. Then start equals the node. So this is start. Just do that. And if end equals null, which it does, then this is also end. Okay. Now we can come up here and go back up here to where we were. So we added the head, then we map.add key and new node. So K1, and we'll call this node 1. We'll just number them. Okay. Now we come up here and we look at K2, D2. Let's say we want to add that in. So if map contains key, it doesn't. So we come down here. We know we need to make a new node. Here's our new node. Previous is null. Next is null. New node.data is data. That's D2. And the key is K1. And then if the map count is greater than the cache size, which it's not, so we need to add to head. Okay, so we're going to add this to our head. Okay, and to add to head, we go down to our add to head function. Node.next equals start. So that means this node equals start. Node.previous is still null. If start does not equal null, which it does not, start.previous, which is this arrow, is going to equal the node. So it's going to point there. And then start equals the node. So this is now start. And if n equals null, n equals start, but n is not null, it's pointing there. Okay, so come back up for our insert. We added the new node to the head. Now map.add key, which is K2, and we'll call that node 2 that it's pointing to. Okay. Now if we want to add another one, K3, D3, it's not in our map, so we come in here and new node. And we know it's got K3, D3. These start out as null. And if map.count is greater than cache size, which it's not, so we just add to head. Let's go ahead and make a little space for it. Okay. And we'll move this to the head. Okay, and to move it to the head, we then go down to our add to head function. So we go down here, node.next equals start. Okay, so our next is going to point to our start. Node.previous equals null. It already does. If start does not equal null, which it doesn't, then starts previous is going to equal to null. I mean to the node. And then start equals node. So now we're pointing our start to this node. And if end equals null, end equals start, but end is not equaling null, it's still pointing to 1. We'll call this node node 3, and we're entering it in the map. Okay, then we go to K4, D4. So K4 is not in the map. So we come in and we're going to insert. And the first thing that we need to do is make a node. This is going to be node number 4. Set our previous to null, our next to null, and we're going to insert our data in there. Okay, and then it says add to head. So we're going to add this to the head. Okay. All right, and it says here that we need to go down to add to head function. Node.next equals the start. So node.next is going to now point here. And node previous is null. If start does not equal null, then start previous is going to now point to our node. And start equals node. So now start is here. And we don't worry about the end because it's not null. Come back up and it says add to the map. So we're going to add our key and it's getting a pointer to node 4. Okay, so last one, K2, D2. So we're going to insert that if map contains the key, and it does. It's right here. So now we know that we can search for our node key and the data. We're going to look for the entry. And so we come into, we come in here and it's going to go to node 2. That's where it's pointing to. And we're going to say that it needs to be moved. So we're going to remove the node first. So to do that, okay, if node.previous does not equal null, which it doesn't, then the previous node previous is next is going to be called nodes next, which means that instead of 3 pointing to 2, 3 is going to point to 1. Then if node.next does not equal null, so here's our node next and it also does not equal null, then we want to set node.next previous, which is this one here, equal to the node's previous. So that will go here. So that 4 or 1 is now pointing to 3. So then after we remove node, we want to then add this node to the head. So it's actually going to get moved up to the head. I'll just kind of stick it here. And so when we move it to the head, we know that it's going to be assigned node.next equals start. So it's going to point here. Node.previous is null. And if start does not equal null, which it doesn't, we move start to this one. And the start previous is going to now point here. So 4 is now pointing to 2. And if end equals null, then end equals start, but end is not null. So now we have moved that into the head position. Now if we go and we want to get one of our items, we would, let's say we want to get K3. Then we can go in, and so if map contains key K3, it does, it's at node 3, so it's going to go down here with the node, because we assigned the node to equal to the map key, and it's going to go down here, and it's going to, now it's going to say you're not the most, you're the most frequently used one now, so we want to move you to the front of the list. So what it's going to do is go down into remove node and then add to head, which we know works. So 3, if we want to remove it, is going to, if node.previous does not equal null, and it doesn't because the 4 is there, then node.previous.next equals nodes next. So this is the next one from the previous node. It's going to go all the way over here and point to 1. Then if node.next does not equal null, which it doesn't, then we want to node.next.previous. So the previous node is going to be pointing now. So 4, the next of 1 is going to now point to 4. Okay, so we now have this detached, and we can move it to the head. And when we move to the head, we end up with choose the head, then we end up with the node.next is equal to start. So this is our node, and its next is going to equal to start. Then its previous equals null. Then start does not equal null. So start's previous, which was null, is now going to point here. And start equals this new node. And our end is actually still null, or is still at the end pointing to 1 over there. So we have done that, and it's going to return the node data because it did find that. All right, so this is going to perform its operations in constant time. So it can add to the map in O of 1 time, it can retrieve from the map in O of 1 time, and it adds and retrieves from the linked list in O of 1 time since it's a doubly linked list. And it can also remove in O of 1, And the space is a constant space. So however large the cache is going to be the size of the space.